All right, so again, to motivate this, it's green light. We're going to move that fire. I can also stand by here. Is that any better? Maybe. So in order to motivate the move to tokens is that, so the primary reason we need to switch is that X509 proxy certificates were never really used much outside of the grid community, and the Globus is no longer supporting their library, and that's where the ones where it came from. So the grid community toolkit, OSG supported that for a while. They took over support of the Globus libraries, but now OSG has stopped support. It depended on the SSL TLS layer that is only very rarely used, and so instead we're switching to JSON web tokens. This is something that's used internally to the OpenID Connect, but we're using it also as basically the payload of OID Connect, and they're potentially more secure because they're fine-grained control. And there's already a lot of existing tools we can use with them, and sometimes and often we need to customize them a little bit. And the SI tokens here of HTCondor, those are JWTs, and with a community standard profile defining the claims in the JWTs. And they're easier to implement than proxies because they're sent at a higher layer in the HTTP authorization header. However, it does make them more complicated to use because of the fine-grained control. When we take advantage of it, it uses up a lot of it takes more effort to take advantage of that, and we end up using it at a lot of different layers. We got ID tokens, side tokens. What Sakib was talking about was to the pilots. Now, what I'm talking about is about not the pilots, but in the user jobs themselves. So it's the next layer up, which our people aren't doing yet. And so it's for using for end users to access storage, including sending them through jobs, with jobs through HTCondor. And keep in mind, and Brian mentioned this too, that X509 host certificates are not going away. They're still very important. So HTCondor already had a couple of solutions before I started working on it. One is the local token issuer solution, where HTCondor issues its own tokens. It doesn't even use Oauth 2 there, but that doesn't scale very well to many submission points because you got to get the keys made available to everybody. And it also only supports a fixed set of JWT scopes. It's not very flexible. They did have an Oauth 2 credentials solution, where HTCondor becomes an Oauth 2 client, and does require web browser interaction, but is before most job submissions, and it doesn't help when you want to use the tokens outside of Condor. So we wanted to minimize the number of web browser interactions and to be able to use the same credentials inside and outside of Condor, and we wanted to make the multiple end user use case as easy as possible. So this is the solution that we are proposing, what we've implemented using Hashicorp Vault with a tool called HTGet token with it. So Hashicorp Vault is a popular open source general purpose secure secret store server. It has a very flexible plugin architecture, and it uses REST and JSON is all the response, and the secrets are stored like in a file system, a path of places where you want to store secrets. It already had existing OIDC and Kerberos plugins. I mean, those need a little extensions, but which we submit to them as a pull request since it's open source, and it behaves as a Oauth 2 OIDC client then, and so it integrates both with both of the token issuers that we're using in the grid community, the Indigo IAM and the CI logon, and then it manages access with another layer of tokens, the vault tokens, and then we use it to store long-lived refresh tokens for a lot of users. So all the users get we store the refresh tokens there in the secure storage server. And then HTGet token is the command line client, and use that to automate the flows. And so initially it will authenticate via OIDC in a web browser. And then the refresh token, which is long life, it can be like a month long, and it's renewable, so that every time you use it, it gets refreshed to get another month. And so that's the high value one. We keep that in Vault, and then we give a limited life, about a week, Vault token that then gets sent to the user's machine. And then even shorter life, the access, the bearer token, JWT, those get stored unencrypted on local files on the user's machine. And it follows the WLCG bearer token discovery standard for local file name. We'll talk a little bit more about that. And then it uses the Vault token to get the bearer tokens out of Vault, and then or it will renew Vault access. So after the week is done, it will then can renew it with either Kerberos or SSH. So this is a picture of the regular flow of OIDC, not using anything special. It's all web-based. Okay, so the user interacts with the web server, and then when we're using federated identity, we go to the OpenID Connect provider. It will then redirect the web browser to come straight to the well, first the web server goes to the OpenID Connect provider, and then it redirects the user browser to the provider where they log in. That redirects to the identity provider, back to them, and then the web server gets that refresh token as well as the access token, and those stay in the web server. Whereas with HTGet token and Vault, the HTGet token and Vault take the place of the web server. So here again, the users uses the command line client first, HTGet token, it connects to Vault, it does the same type of thing as a normal OIDC flow, talks to the provider, but then we redirect the user over to their web browser for this first time. And then the user's browser again goes to the OpenID Connect provider, identity provider, and back. And here, the difference is then the refresh token stays in Vault. Vault issues a Vault token, and then the access token goes to the client where they can be used for other purposes. So let me tell you a little bit about, we've defined this thing called capability sets. So first of all, JWTs can be tailored to a minimum privilege by use of capabilities. These are scopes with access limits. And you can also have specific audiences of which servers that we want these tokens to be for. So the knowledge of what scopes are allowed for users is maintained by the OIDC provider, the token issuer. And this information doesn't need to be known by the OIDC clients. So what we do is we configure Vault, and we configure the token issuer to have this thing called a capability set, where then the token issuer then will translate that into a set of capability scopes. So then the groups, they will correspond to a VO, and it corresponds to either a VO, a virtual organization, or a role within the VO. Each of these groups goes to a different set of scopes within a VO or role. The bulk configuration then gets done per issuer. So we have one VO per issuer. This is the issuer is a Vault term, and then also a role. And each of those will map to a capability set. So here's an example. So we would say HTGet token, the name of the Vault server, the name of the issuer is the VO name, and then a role within that VO. And so then that Vault will then translate that into a token issuer URL, and then also the capability set. So normally with HTGet token operation, it will first, you give it a Vault server address. I showed that example, and an issuer name, and optionally role. Then HTGet token will always get an access token and stored in a file. And the file it stores it in is according to the WLCG bearer token discovery. It's basically, we use this XDG runtime drawer as a place in memory, typically per login user per session, and then it's stored that under a bearer token name and the user ID. Then the first time HTGet token will use the OIDC authentication, and additionally gets 2 more files. So it's the vault token, which is stored under a similar name, but in /temp, so it can be saved for a week on that machine. And it also has a thing called the cred key. This is just a term that HTGet token uses, and this gets stored under the user's home directory, and it defines a part of the storage path that is in Vault. And that's for the issuer and the role, per issuer and role. And this information comes from the token issuer based on who authenticated in the web browser. So if the cred key file exists, but the vault token doesn't work, and that situation, then say for example, the vault token is expired after a week, or if you're switching between different issuers or roles, then HTGet token will attempt Kerberos authentication to get the new vault, or if the Kerberos credential is not available or it fails, then it will also try SSH agent if that's available to get a new vault token. And HTGet token has a ton of options for tailoring that. So here's an example of using HTGet token by itself. The initial flow, and it will goes to OIDC token, and then it says to complete the authentication at this web URL, go there to the web browser, log in, user go to their identity provider, your home institution's identity provider. And then once that's done, it will store the vault token, cred key, and then store the refresh token and get the bearer token and store that. And here's a couple more examples with once it already has a valid vault token, all it does is it gets the cred key and uses that to get a new bearer token. Or if it needs to get a new vault token, it will say, all right, it uses Kerberos to get a new vault token, stores that, and then stores the bearer token. So HTGet token knows which flow to use depending on the situation, but it always ends up with an access token, unless you tell it not to, but that's the default. And then it also comes with a tool called HT Token Decode. -H, it tells you human readable dates on them, but tells you the list of scopes and the expiration date, time it was issued, things like that, where it came from. There's a package for configuring Vault called HT Vault Config, and that's for specifically to configure the Vault to be used with HTGet token. And it will automate all the installation, set up a Vault, and then the configuration of it is done through YAML files. And it includes a modified Hashicorp plugin and two additional plugins, and then to Vault, and it also supports this option, which Vault has a built-in capability of using multiple servers for high availability, and so it supports using 3 servers. And it's available in OSG, along with Vault itself and HTGet token. So now talking about the integration with HTCondor. So they've been integrated together, and what can happen is Condor Submit can be configured. If you want to install basically Condor Credmon Vault, it will be automatically configured to invoke HTGet token as needed. And then it will store a Vault token also in the cred. And the Vault token then used by the cred, which is actually Condor Credmon Vault. Credmon is a plugin basically to cred. Then it will get the new short-lived access tokens to push and keep on refreshing jobs, so the jobs always have updated access tokens. And then the submit file specifies the issuer, optionally the role, and after they can choose a reduced audience and scopes if you want to limit your token further. And I'll give more details in the upcoming slides. So it can obtain more than 1 per job, and that part is based on the implementation that HTCondor already had with Oauth 2 credential support. And it's in HTCondor, not 9.0, but early on in the 9.0 series and all later HTCondor versions. So here's a picture of the way all the pieces work. So the user submits a job and runs Condor Submit. Condor Submit calls out to this plugin to Condor Submit called Condor Vault Store. and that's installed on the machine. That calls HTGet token, which will then connect to Vault and the token issuer. You'll end up the first time through again, ask the user to go to the web browser and go to the identity provider, and this sends back the access token, refresh token to Vault, and the Vault sends the Vault token back to the Condor Vault store. And this Vault token is more than a week long. This is like a 4-week token. And then that gets Condor Vault store, passes that on to Condor CredD, and stores it in Condor CredD, that 4-week token. And then Condor CredD Vault knows how to use that. That's a plugin to Condor CredD. It knows how to use that Vault token to get new access tokens from Vault whenever it needs it. And then the job goes through the normal mechanism with the Condor, gets submitted to Condor SCED. Condor SCED and CredD are tied together pretty closely. And then the Condor Shadow takes that access token and pushes it on to the user's job, or the user can use it to access data, whatever they need to do with the token. So the HTCondor configuration is pretty simple. Once you install the Condor CredD Vault RPM on both the submit machine and the SCED if they're different, and then you just need to tell it the name of the Vault server, which HTGet token ops it needs to add by default in, basically the name of the Vault server. And then submit files have this syntax, which came from the Oauth 2 support in HTCondor. So first you have to say use Oauth services, which is the name of your VO, the issuer in Vault. And then these are optional. That should be all you need to do is the name of the service, and it can also include the role name. If you want to say Doom Production, you could put that in the name of the service. But then if you want to decrease the scopes or decrease they call it resize here, but it's the audience in JWTs. Then you can put those also in the submit file to reduce the list that you want. And then in addition, you can have more than one. For each of those, you can add one more, append a handle or whatever name you want to have like different set of credentials. If you want to do different things and the job wants to have one that's read-only, one's read-write, for example, then you can list different scopes if you want and give them a name. And then all the tokens ends up in this directory with a job, which is $_Condor_creds, which again was already built into HTCondor. Let's see, I go backwards. Yeah. So one more thing is I want to talk about robot unattended operation. So these are really important for lots of tasks. You're doing like production job. You have things that are done with a VO, has a lot of stuff that need to do in common for the whole project, as opposed to an individual researcher submitting jobs. And so there are ways to do that. You can have the Vault administrator create an indefinitely renewable Vault token for those robots. That's one way to do it. Or you could give them their own OIDC client ID in secret and bypass Vault completely. But we found that it's more convenient for us, for users, to be able to get Kerberos credentials in our case. It could be also done with SSH. Could also be done with SSH keys, but HTGet token and HTVault config then support the use of robot Kerberos credentials to get new Vault tokens. And so those are then long-lived. They get stored unencrypted on this robot machine. And then the principles are typically in the form of this is the way it is at Fermilab, I've seen it also in LIGO and others. You basically have the user's account name, and then some purpose with it, and then the machine name that it's for. And then this can also be a group login, either user's login or a group login. And then the user or the authorized user for a group can go through that web browser OIDC authentication once, and then specify this extra option cred key, which is a path matching this whole Kerberos principle. And then that will then store that basically as a subpath under the user's Vault. So users can get permission to write under their user ID or groups get to permission to write under the group name. But then with CredKey, they're going to put this basically as a subpath in the file system. And so they're allowed to write to anything under your subpath. But then the reader, the robot credentials can read this back from just this subpath. And SSH agent can also be used with authorized keys. There still needs some work to be done on how to manage the keys, but that support is involved now in HT. Can I get backwards again? All right, so getting credentials is gets with this system is almost as hidden as they can be from the user. They just need to go to the web browser once, and then as long as they submit jobs once a month, then they don't need to do it again. And then if you have Kerberos or SSH agent available. And then configuration gets managed by the server operators. And then so it's very little necessary for users to do even maybe a little bit if they for those configurations in the submit files. Those will probably actually typically be done by scripts per VO. So end users don't need to do much at all. And then all the protocols are in common industry use, and the JWTs are better supported and more secure than X509. And all the tools are open source and generally available. So have links if you wanted to see anything from the easier, of course, to download it from the Indico.
All right, let's thank our speaker.